last video, we discussed about empirical rule in normal distributions, what is standard deviation, sigma or average, right? In this video, we will discuss the example, the real world example, to get the clear understandings how we can use the empirical rule, sigma rule in the real world data set. I have a data set, with the population, which is the population of the student's height, right? This is the distribution which is representing the population of the student heights, right? So in this video, I'm going to tell which are those students with height, they are representing the 68% in the distribution, which are those students which are with height that representing the 95% of data in this distribution, which are those students with height which are representing the 99.7% in this distribution. So here you can see I have an average of the students' heights, which is the 5.5 unit. I can say unit, not inches or centimeters. This is or with the standard deviations 0.5, right? So here the average center, the average of the students, of the those with the height is 5.5. Means average student has height 5.5 units, right? Now with the standard deviation 0.5, the next value will be 6, 6.5, and 7, and the below 5, 4.5, and 7. With respect to the sigma, 2 minus 2 sigma, minus 3 sigma, 1 sigma, 3 sigma, 1 sigma, 2 sigma, 3 sigma. Now if you can see here, the heights of the students between 5 to 6, spread of the data whose height is between 5 to 6 are representing the 68%, and those students whose height is between 5 to 6, they are representing the 68% in this distribution. Now if we see the second deviation, which is 6.50 and minus 4.5. Now the distribution, the data whose deviation till that point is representing the 95%. And the students who has a height between 4.5 to 6.5 are representing the 95% data set in this distribution. Now those with the students who has height between 4 to 7 unit with the 3 sigma, or you can say they are representing the 99.7%. So here you can see how empirical rule can be used in with the real world data set. If you notice, I have used this distribution is the population distribution. How can I say this? Whether it's a population or a that it is sample, this distribution is representing the sample or the population. This is also a question, very important question related to this topic. So I have used the parameters sigma and mu. So here the one concept you can see, which is a population and sample. If there is a normal distributions following the data of the population, the average of this distribution will be mu and the standard deviation will be sigma, and these parameters, these are known will be parameters. If the data set from population, their mean will be mu and the standard deviation will be sigma, and these will be known as the parameter. If the data set or the normal distribution is taken from the sample data, the sample mean will be x bar and the standard deviation will be s, right? And x bar and s will be known as statistics, right? So this is the basic difference between the parameters and the statistics, right? The mean and the standard deviations from the population, these are known as the parameters with a sample of mu and sigma. If the data set is taken from the sample, their mean is the x bar and the standard deviation s. These will be representing the statistics, known as the statistics. That is the difference between the parameter and the statistics. So that is all about this video.